Hello everybody, Wishbone8121 here, and just as a quick introduction, this is going to be a basic overview of bioweapons kind of theory. I'm making this actually for vivabarneslaw.locals.com, which I am a member of. They did not solicit this, I am just making it of my own accord. Based off of the recent indications that the bioweapons labs in Ukraine, which were funded using Hunter Biden as an intermediary, were actually being used to target Russians specifically. Anyway, since actually today I'll be using myself as the expert witness, I guess I'm going to have to go over my qualifications. Now I'm not, I don't have a PhD. I was one course away from getting a Bachelor's of Science in Biochemistry from Wayne State University, but I never did my senior research project. So I just have a BA instead in chemistry. Now, as far as biochem goes, I did take Chem 5600 and 6640, which is Introduction to Biochemistry and Molecular Biology. According to Professor Bhagwat, who taught there for 20 years at this point, he said that I had the highest grade in both of his classes out of every single person who ever took them, during his 20 years. Now, considering that that's a requirement for everyone that gets a BS or a master's, because it is a hybrid bachelor's and graduate course, that means I did pretty good. Although really my real qualification in this kind of thing, I would say, would be my reaction the first day I heard about the vaccines that Trump was thinking about making before Project Warp Speed was announced. And my off-the-cuff immediate reaction was to tell people that it was a very, very, very stupid idea. Incredibly stupid. Because the idea of making a vaccine for a single-stranded RNA virus such as coronavirus, which mutates extremely fast, would never actually produce immunity within a population. It would actually just induce a selective pressure, which would cause the alternate versions of quickly mutating virus to become the main strain and thereby bypass any vaccine-mediated immunity. Furthermore, I told people that as the disease progressed, because it is it is extremely infectious and rapidly mutating virus, that it would constantly have new variations that were less deadly and more contagious until the virus returned to its natural state, which wouldn't take that long anyway. So the two things you can mainly take away from this is that even people with just a bachelor's degree in biochemistry would be able to tell you that our health doctors were completely lying to you and evil. And it wasn't that they were incompetent; it's that they were evil. They were purposely lying. And the second thing you can take away is that you should probably listen to someone like me over someone like Fauci. So with introductions aside, let's get into the science. To give a little bit of a science background involving bioweapons, basically the basics of how to make a bioweapon and how and why it will affect different groups of people differently. It's actually not that complicated. That portion's actually not that bad. First of all, we need to know the difference between immunity and resistance, because if you're going to make a bioweapon, you want to penetrate both in your target population. So let's start with immunity. There's two main types of immunity. Now, immunity is your defense from your immune system. So this is something that is based off of you actually your immune cells, your B cells and T cells, coming across an actual foreign substance. The way this works is I guess I'll kind of to save it on time skip how it happens, but I'll just give you the effects of it happening. B cells, when they are in contact with a foreign object, will produce antibodies. Now, antibodies in the future, they can bind to either the same substance you were exposed to, or a substance that's analogous, something that looks similar, provided that analogous substance has the identical, that is exact same binding site where the antibody is actually touching. And they bind to it. It renders it inert and allows your other parts of your immune system to target it for destruction. Similarly, T cell immunity is kind of similar. T cells don't produce antibodies. However, they do crawl around your cells, and they can they basically feel your cells, and if your cells are producing foreign proteins, specifically the foreign proteins that it has kind of learned about by touching, they'll feel it as they're crawling across it, and they'll be able to tell that cell is infected with something, and then they'll shoot little cytokines. Basically, they talk to that cell and force that cell to commit suicide, and then in a way that will be preventative from it, so it won't release any viruses. Basically, eats itself. One thing to think about while looking at this is, in the public mind, we all remember that with the coronavirus pandemic, there was an original variant, and then Delta was the big variant, which had some genetic mutations, especially within the region of the spike protein, which is what the COVID shot was based off of. So the COVID shot, it exposes you a lot to the original variant's spike protein, which over time is less and less useful, which at the time, now with the Omicron variant being the major variant, Omicron, the spike protein is so different that the original COVID shot really almost does nothing, because there's so many differences between the original variant's spike protein and the Omicron spike protein. So now with natural immunity, this difference still exists, but it's less profound, because natural immunity that's based off of actually getting the virus and not just the shot affects more than just the spike protein. It basically allows you to generate antibodies against all the proteins on the viral surface, and potentially ones on the inside as well, but the viral surface ones, I'm pretty sure, are the most important. And that's not really even taking into account the fact that the way the mRNA vaccines work is very artificial and is a very unnatural way of producing immunity. But anyway, so immunity has to do with your response to something that looks similar. And just like people with immunity to the original variant still have decent immunity to the Omicron, if you were making a bioweapon, you would want to make sure that your bioweapon does not look anything like a virus that's in the target population, because they would have immunity if you infect them with a similar virus. That would be a virus that has surface proteins that look like one that's in their population. Okay, so let's go on to resistance. Now, resistance is very different than immunity. It is not based off of your white blood cells in any way, or your response, but rather it's based off of how the virus gains access into your cells, and in any mechanisms that can possibly cause death within an infected person. But before we get into resistance per se, we first have to kind of lay a foundation of how a virus gets into your cells, because that's an important point. To take just a very basic example, which I can just give from memory, HIV, the virus that causes AIDS, the way it works is it will bind to the CD4 receptor of a T helper cell. Now, T helper cell, it's one of your immune cells. Basically, that CD4 receptor, normally, it allows your T helper cells to talk to other T cells. I'm pretty sure that's what it does anyway. But what the HIV virus does is it pretends to be another T cell. It binds to that CD4 receptor, and whereas normally your T helper cell is thinking when something binds to that receptor, it's thinking that, I'm gonna receive some packet of information from the outside from another T cell, and it gobbles up whatever it is that's attached to the receptor. What happens instead is it gets tricked by the HIV virus and binds to the HIV virus and pulls it into the cell and eats it, and then that cell now is unwitting factory of more HIV virus. That's basically how that works. And with that out of the way, we can introduce the first type of resistance I'm going to talk about. This one being the natural resistance associated with blocking the infiltration of a virus due to having a genetic mutation in your alleles. Think of, say in this case, hypothetically, what would happen if if you had a mutant version of CD4, where the CD4 receptor could still bind to your receptors on your other T cells, so its immune component still functioned normally. However, what if it could no longer bind to the active site of HIV? Now, at this point, you have to keep in mind that for most chromosomes, other than the X chromosome in men, you have 2 copies of each gene. So if you only have 1 copy of this allele, then you would have a small amount of resistance afforded to you. It wouldn't affect it as much. However, any person, if they had 2 copies of this allele, would be fully resistant to this virus. They would not even be able to get infected. You could literally inject yourself with a virus and it could never hurt you. Now, because of this, it would make sense then, and this is actually the case, where when you have a virus that is indigenous to a population and has been, going around for, 2,000-3,000 years, the incidence of mutant alleles, of proteins that are involved in the invasion of those viruses, basically the proteins those viruses attach to in order to get into the cell, have mutations, occur in much greater numbers in those population groups, because those people won't die from the virus. So there's a selective pressure from the virus being constantly within that population to kind of choose and proliferate those mutant alleles. So that's our first type of resistance, basically resistance to the binding site of the virus. So those people that are fully resistant to the binding of a virus can't get sick. However, another form of resistance within a population has to do with basically protecting you from however the virus kills you. Just to go into an example for that, we can just use COVID as an example. The primary method that a mechanism that people die of in regard to COVID has to do with respiratory distress, which is the same as SARS, actually, another coronavirus, shocker, which basically, it's actually an immune-mediated response where your immune system kind of overreacts and in the lungs, causing you to basically shut down due to an overstimulation of the immune system within the lungs. Now, I only took advanced human physiology, which is just a 3-credit course, so I'm not super knowledgeable about this type of thing, but I would imagine that a theoretical type of resistance that could emerge in this type of a population, which is had coronaviruses going around for a few thousand years, would be that the histamine receptors in the lungs could be mutated in such a way that their sensitivity to histamine would be diminished, or maybe instead of histamine, any other type of immune signaling molecule. Now, if it is diminished, then for this person, they would be much less likely to die from coronavirus because their lungs would have a reduced immune response to infections, and this person would not overreact by putting water into their lungs from the coronavirus. So you could see how in the Chinese population you would expect there to be a decent number of mutant alleles and a proliferation of such alleles, or perhaps even the expression, a reduced expression of these cell surface proteins, which bind to immune signaling molecules inside of the lungs. So that's just another example, a theoretical example, but an example nonetheless of natural resistance to a mechanism of death. So now that we understand the kind of science behind how resistance works, we can look at some historical examples of resistance in populations. This is the difference between the European populations versus the Native American populations. When you look at, say, smallpox. Now, I don't know the specifics about smallpox, but suffice it to say, when the settlers came with a little bit of smallpox over to America, the Native Americans got basically obliterated because they had no natural resistance to smallpox, and smallpox is very deadly. Conversely, the population of European Americans was not widely affected because natural resistance to smallpox is very high in that population. So, now going on. So basically, if you want to make a bioweapon, you want to be able to penetrate both immunity and resistance, especially in the target population. Now, in order to penetrate immunity, what most bioweapons use is that they use an animal version of a virus. Basically, you want most of the exterior proteins on your virus to be from an animal version of the virus that you're using. So that's why you want to use like bird flu or swine flu or bat coronavirus. So a lot of the external proteins used to make your kind of your protein coat, you would want to use from an animal. That way, none of the human populations don't have an immunity, meaning they don't have antibodies that are similar to something else that binds to your bioweapon. However, that does not deal with resistance. In fact, and the reason why you can't just use a straight up animal virus is that the animal virus won't have that invasion technique. They won't the protein used to actually invade the cell, the one that tricks the CD4 receptors, say in HIV, it won't be proper. So what you have to do is then you have to splice a normal human protein that actually does the invading into your bioweapon here. So the way that you make sure that the bioweapon specifically targets the people group that you're looking for is you use a virus that is not that's never really infected that group of people before. In fact, if you pick one that has infected your people for, say, 4,000 years, such as with a Chinese coronavirus, that other populations such as America or Europe have had a very low exposure to, then what you'll have is the Chinese population will have extremely high rates of resistance. That is, a number of people within their population that have proteins that viruses can't bind to properly, so they can't actually infect them, or other mutations which basically cause the coronavirus to be less deadly to them. Whereas populations, say, in Europe and America or Africa or South America, because these people groups have had very low exposure to the Chinese coronaviruses, will have no innate resistance. Their proteins will just be wide open and very easily bindable to the coronavirus infiltration protein, and they'll have no innate resistances to things that cause death. So basically, you can see where the COVID-19, being that it was from a bat, meaning it bypasses everyone's natural immunity. No one's going to have any innate antibodies to it from whatever coronaviruses that they've had in their life. And then if you use specifically a Chinese coronavirus, specifically you'd want a variant that has not been passed around worldwide, at least not recently, not for very long. It takes quite a while. I'd say multiple, dozens of generations in order to build up resistance. And the number of generations it takes to generate resistance in a population is going to be inversely proportional to the deadliness of the virus. So something like a Chinese coronavirus would take thousands of years to produce immunity, whereas something like Ebola would probably only take maybe 100. And as far as these numbers goes, I'm just guessing. It's an educated guess, but conceptually, the concept is still real. So if you're making a bioweapon against America and you were Chinese, you could use a Chinese coronavirus that's been in China for 4,000 years. As long as it's only been in America for 200 or 300, you should be fine. So Americans and Africans and people from South America won't have any resistance, so they'll be very affected by the virus, whereas the Chinese people should be fine, as will most anybody that's been in very close contact with the Chinese people for the last 4,000 years. Even though they won't have immunity, they will have a natural resistance, meaning their proteins will not be will have high mutation rates of the proteins needed for the virus to gain access into their cells. So basically, also just moving on, this is just two parts of making a bioweapon. Your third part is, besides splicing those things together, you want most of the outside to be the animal parts, and then you want, of course, to have the infiltration protein be a human one, specifically one that your population has been exposed to for a couple thousand years, and your opponent population hasn't really seen that much of. And that's actually kind of the easy part, because you just need someone with a decent amount of history in diseases to basically pick that particular virus out. And the hard part, obviously, is splicing those two together is, beyond me as far as its complication. Because making sure the virus can assemble itself properly is pretty complicated. And then even more complicated than that is doing things like addition of function mutations. An example of like an addition of function mutation is to say you want a coronavirus to be very transmissible through, say, airborne, very high airborne transmission. What you'd want to do is take, say, a part of another virus's, say, a flu virus's ability to maintain moisture on its surface, so that it can survive within air for longer periods of time. And you'd want to take that protein or protein part and splice it into your bioweapon, so that your bioweapon now has that flu virus's ability to maintain a moisture around itself while in air, so that it can survive in air longer. Something like that ends up being very, very complicated and difficult to perform. That's why it takes lots of researches and lots of money in order to make real bioweapons. However, making sure that your bioweapon will hurt another population more than yours is actually not that complicated. It's just a very simple choice based off of history. Anyone with a with a history book or Wikipedia should be able to figure out a group of viruses that would work for their population, that would not affect their population as much as a target population. Now, in this particular case, we're talking about Slavs, which, because Eastern and Western Europe have very similar histories and very similar genetics, I would suspect that any bioweapon made against Russia would actually have a decent impact on Europe and America as well. I don't know if it would actually be possible to make a bioweapon that hurt Russia particularly badly compared to America. You'd probably end up having to use a virus from Africa or something to really do that properly, which it's gonna basically hurt all white people about the same anyway. But then again, I'm not a PhD, and I'm not a virus historian, so I don't know that for sure. Perhaps there are some viruses that would work in that context, but just a very basic overview of thinking about this for 20 minutes. I'm not really sure if that's feasible. So I highly suspect that our genius people in the White House, or not in the White House, but in the deep state, really don't care about casualties in America. And in fact, considering Bill Gates' position on the matter, he might want it to hurt America just as bad as it hurts Russia, because they that's their thing anyway. And I'll just end us out with a little disclaimer. I'm not an expert. I don't have a PhD. I'm just to be honest, I'm much smarter than our experts are, and I'm much, much, much more honest than they are. And I do not approve of bioweapons. I think that they're horrible. I think that they are a double-edged sword, and that doing that to other people is evil. In fact, I'm not even entirely sure how I feel about genetic manipulation at all, but I could see where in some cases it might be helpful, like making crops that could grow in a desert, or fixing genetic mutations in humans. Either of these would be a far better use of time, though even with that still, I'm still not sure exactly how I feel about it morally. But anyway, you guys have a nice day.